In today's video, we're going to learn how to find the volume of cylinders and cones. There's nothing new really involved in this. We've learned everything we need already. We're just going to apply it in a different way. So what is volume? Volume is the amount of three-dimensional space occupied by an object. And sometimes volume also referred to as capacity. To calculate the volume of something, we're going to multiply the area of the base by the height of the cylinder. You might want to keep in mind that the height is not always the vertical distance, so it's not always going from the top to the bottom. It's just the distance between the bases of an object. Right, so the formula can be written as V equals BH, where V stands for volume, the B stands for the base of the object, in this case a cylinder, and H stands for the height or distance between bases. Now the base of a cylinder is always going to be a circle. And to find the area of the base, we have to use the area formula of a circle, which is pi r squared. So now let's look at some examples of how we can use the volume formula to calculate the volume. So our instructions here for these examples, they're asking us to find the volume of each cylinder, and it specifically tells us to use 3.14 for pi. When doing these problems, read carefully. If it doesn't tell us to use 3.14, we're not going to use 3.14. We're going to keep the pi symbol, and I'll show you how we can work the formulas when we do that. So we'll start with the formula, which is V equal BH. Now remember, the base of a cylinder is a circle, and we're finding the area of that. So we're going to replace the B with pi r squared. So that part of the formula there, this represents the area of the circle. And then we're going to multiply it by the height. So now we'll go ahead and we'll plug in the values. We'll substitute the values, the variables with our values. So we're using 3.14 for pi. We're multiplying it by the radius squared. So we're going to multiply by 6 squared. And then we're going to multiply it by the height, which is 4. So let's go ahead and use that in our calculator. So we're doing 3.14 times 6 squared times 4, which equals 452.16. Now we have to use a label, and for volume the label is inches cubed because we're talking about three-dimensional objects. So we use cubed for that because of the 3 dimensions. All right, so looking at problem number 2, let's just compare it here to problem number 1 and see if there's anything different. In problem number 2, our cylinder is now on its side. We've got to keep that in mind. This is our height here, 10 centimeters. That's the distance between the bases, between the circle on the left, right here, and the circle on the right there. And the height, or I should say the diameter, this is the diameter of the circle. Remember, the diameter is a line that goes from one side of the circle through the center to the other side. Now we need the radius, right? Not diameter. Our formula calls for the radius squared. So the radius is half of the diameter. So in this case, r equals 4. So just be careful for that when you're doing the problems. You don't want to plug in the 8 in this case because that would be the diameter. So our formula is 3.14 times 4 squared times 10. So we'll go ahead and plug that into the calculator. 3.14 times 4 squared times 10, which is 502.4 centimeters cubed. Again, don't forget the label. So earlier in the video, I said we would use 3.14 if we're told to use 3.14, and we would keep the pi symbol if we're not told to use 3.14. So when we keep the pi in our symbol, that's usually referred to as in terms of pi. What that means is that we're going to multiply everything together except for the pi symbol, and we're just going to leave that pi symbol in our answer. So let's look at number 5. So looking at the circle, here's the height. It's the distance between the two bases. And again, we have a diameter here, and we need the radius. So in this case, the radius is 8. So we're going to put these values into the formula. Notice how I've kept the pi symbol there. Now we're going to do the same thing as before. We're going to use our calculator, but this time instead of using the 3.14, we're just going to do 8 squared times 7, which is 448. So we're going to say V equals 448 pi inches cubed. In a lot of ways, this is actually easier. It's one less thing to enter into the calculator and multiply. If the problem doesn't specifically say to multiply by 3.14, but the instructions tell you to round to the nearest tenth, that means we're going to have to use the pi symbol or 3.14 in our calculator. So we would do 8 squared times 7 times 3.14. You see here we've got 1,406.72. So we're going to round to the tenths place. That's the first place after the decimal. And when we look at the hundredths place there, because it's less than 5, we round down to the 0.7. So our volume would be 1,406.7 inches cubed. All right, we have a word problem in front of us now. So we're going to read this carefully, get all the information we need, and see what it is we have to do. So it says the volume of a cylinder is 942 cubic feet. All right, that's a little different here because it's telling us what the volume is, look. In all of the other problems, we had to calculate the volume, but now we know what it is. So let's see if there's anything else that's different. It says the height of the cylinder is 12 feet. What is the radius? So this problem is a little different because now we're being asked to find the radius. We can still use the volume formula. So V equals pi r squared h, but we're going to replace the values with what we know, which is normal. We do that anyway. So that's 942. That's our volume. We're not told to use 3.14, so we're going to keep the pi symbol. We don't know what the radius is, but we do know what the height is. It's 12. So now we're going to go ahead and we're going to use this. And we're going to divide both sides of the equation by 12 pi. And the reason we're dividing by 12 pi is because this all here is multiplication, right? It's pi r squared 12. And we're trying to isolate the r. And the way that we do that is we undo the multiplication with division. So we'll go to our calculator. We're going to do 942 divided by 12 pi. We get 24.987. Well, that's about, this is a long decimal, that is about 25. So I'm just going to round that to 25. And now we're being asked what number multiplied by itself is 25. And we know from our work yesterday that the answer to this would be 5. So the answer here is going to be, the radius is 5 feet. We'll now turn our attention to the volume of cones. So here we have a cylinder and a cone. They both have the same base. So the diameter of this base and the diameter of that base are the same. Notice, right, the height of these is also the same. So what do we notice then about the volumes of each when the bases and the heights are the same? Well, the volume of the cylinder in this case is 120 inches cubed, and the volume here is 40 inches cubed. That to me looks like it's about 3 times less than 120. Let's just look at one more example and see if that pattern holds true. So again, we can see the diameter here and the diameter here are the same. And the heights, which is, if you remember, the distance between the bases, is also the same. So those measurements are equal for both. And again, this looks like it's about 1/3 of the volume of the cylinder. And that's not a coincidence. The volume of cones will be 1/3 of a cylinder that has the same base and height. How is that helpful for us? Well, it's helpful in the sense that we can use the volume formula for a cylinder, but then take 1/3 of it to find the volume of the cone. So we're going to adapt our formula to show that, and we'll do that right now. So we've just looked at how the volume of a cone will always be 1/3 the volume of a cylinder with the same height and radius. And to include this change in the formula, we're going to say that the volume is 1/3 of the base times the height. And sometimes you might see it written as this. They're the same thing, just written slightly differently. Now, since the base of a cone is a circle, the area of the base is still going to be pi r squared. All right, let's now look at some examples. So let's look at our first example here, and we can see that we have a radius of 5 on the base, and we have a height of 12. So very similar to cylinder problems with the types of measurements we're given. Our formula is V equals 1/3 pi r squared h. So it's the same formula as that of the cylinder, but with the 1/3. We're going to do what we did before. We're going to substitute the values that we know into the variables. So we don't know the volume. We're going to use 3.14 for pi, so times 3.14 times 5 squared times 12. So let's do this on our calculator now. So I'm going to start with the 1/3, and the way that I'm going to do that is I'm going to use a parenthesis. I'm going to do 1 divided by 3. So this is telling the calculator we want to use 1/3. We're going to multiply it by 3.14. And we're going to multiply it by 5 squared. And we're going to multiply by 12. And we get a nice whole number here of 314. And we need to include the label, which is inches cubed. So that's really the only difference, is in the calculator, we're going to use the 1 divided by 3 in parentheses to represent 1/3. Other than that, it's very much the same as finding the volume of a cylinder. So we'll look at 2 more examples now, just to make sure we've got a complete picture of this. So we have a cone here. Again, look, diameter. We don't want diameter, we want radius. So the radius is 11 centimeters. Our height is still 10. So V equals 1/3 pi r squared h is the formula. When we replace the values, we've got 1/3 times 3.14 times 11 squared multiplied by 10. So we'll go ahead and plug that into our calculator. So again, I'm going to use a parenthesis, 1 divided by 3, close parenthesis, there's the 1/3, times 3.14 times 11 squared times 10. Now we get a gnarly looking decimal there. Do we have anything in our instructions for rounding? We don't, but what I'm going to do is I'm gonna then keep it to the hundredths place. I can see that 6 is repeating. Now the reason there's a 7 on the end is because the calculator has to cut off the repeating part at some point, and then it rounds the last digit up. So this is really 1,266.46 repeating centimeters cubed.